Hi everyone, today we are going to be reviewing how to find the length of segments in circles using the segments and circles maze. You can find this posted to OMHS in the blank class notes, and the key will also be posted to OMHS in the filled in notes. Please stay tuned at the end of this video for the attendance word. It'll be given to you in a interaction. You won't hear me say it out loud, so just pay attention to that interaction at the end to find out the attendance word. When we solve a maze like this, we always start at the start. We answer the question, and then when we have the answer, we follow the path to the next problem. So let's start here at start. Okay. So we are looking at this problem here where we are solving for x. Find x. So when we want to solve a problem like this, we will use the relationship that we know about two chords that intersect inside of a circle. So I'm going to just take this onto a new slide so that we have more space to work. Here it is. So in this circle, we have two chords that intersect. The relationship says that you can multiply the two pieces together. So I'm going to take 14 times 18 and 21 times x. Those will be equal. And now we can solve for x. So we can use a calculator to find 14 times 18. And then we'll divide both sides by 21. So our answer is x equals 12. That's what it wanted us to find. X is 12. So when we go back to our maze, we are going to follow the path of 12, which tells us that we are now going to solve this problem next. See how it works? Here we are. Find x. Do this problem now. So for this problem, we are going to multiply 16 times 5x minus 11 and 38.4 times 10. Those will be equal. When we solve a problem like this, we have to remember to distribute that 16 to both parts. So we get 80x minus 176 equals, and now I can just multiply 38.4 times 10, 384. And now we're just going to solve for x. I'm going to add 176 to both sides. And I get 80x equals 560. And divide both sides by 80, x equals 7. Okay, that was my problem, find x. So now I can follow the path of 7. Okay. Next problem, we are going to find CD. Be very careful. It is not asking us to solve for x only, but we have to find the length of CD. So once you find x, find the length of CD. Try that now. So to find CD, the first thing we're going to have to do is find x. Even though it didn't specifically ask us for x, we're going to solve for x, and then we'll be able to use that to find CD. So what we're going to do is these intersect inside the circle still. So 10 times x plus 4 and 15 times x minus 2. Don't forget those parentheses. You're going to want them so you remember to distribute. So let's distribute the 10 and the 15. 10x plus 40, 15x minus 30. I'm going to subtract 10x from both sides and add a 30 to both sides. And then I'll divide both sides by 5. So x equals 14. Okay, that's x, but that's not CD. So let's find CD. Okay, I'm going to plug in a 14. So CD is this entire chord. This piece is 10 and this piece is 18. So the length of CD is going to be the sum of 10 and 18, 28. So when we look at the maze, we are going to follow the path of 28. Many students right here on this step get this part wrong because they didn't follow the directions. See how 14 is there? They followed 14 and then they ended up not finishing the puzzle correctly. So make sure that you actually answer the question of finding CD so that way you can follow the correct path. Now that we know that we are in this box, go ahead and find the length of JK. Do that now. Okay, so to find JK, we are going to take our parts and multiply them together. 16 times 3x plus 6. And these parts, 14 times 7x minus 11. And we will distribute. So 16 times 3 is 48. So this is 48x. 16 times 6 is 96. 14 times 7 is 98. So this is 98x. And 14 times 11 is 154. Let's see, let's subtract 48x from both sides. So I get 96 equals 50x minus 154. I'm going to add 154 to both sides. 250 equals 50x. And then we'll divide both sides by 50. That gives me 5. X equals 5 is a lovely solution for x, but it doesn't answer the question. So let's find JK. This would be 3 times 5 plus 6. 15 plus 6 is 21. So the entire length of JK will be 21 plus 16. So our answer is 37. So on our maze, we are now going up here. Now this problem is different than what we were just doing, so let's do this one together. We're going to solve for x. And in this problem, we don't have an intersection inside the circle. We have the intersection outside the circle. So the relationship is going to be a little different. Remember, the relationship here says that we're going to take the piece on the outside and multiply it by the length of the whole thing. So here, the piece on the outside is 9, and the length of the whole thing is not 15, but it's 9 plus 15. So you can write 9 plus 15 inside, or you could just add them together and put a 24. Equals, now the length of the outside here is 8. The length of the whole thing is going to be 8 plus x, or x plus 8, either way. Well, 9 times 24 is 216. 8 times 8 is 64. 8 times x is 8x. I'm going to subtract 64 from both sides. Get 152 equals 8x. Divide both sides by 8. X equals 19. That's what it was asking for. So 19 is our answer. That takes us to this box. Find x. So we're looking at this box right here. Go ahead and solve for x in that problem. Do that now. So for this problem, you're going to set it up by saying 7, that's the piece on the outside, times the length of the whole thing. The length of the whole thing will be each of these pieces added together. So 7 plus 2x plus 3. Over here, the piece on the outside is 6. And the length of this whole thing will be 6 plus 4x minus 1. Before I distribute, it's a very good idea to combine any like terms inside your parentheses. 7 plus 3 is 10. Then over here, 6 minus 1 is 5. If you don't do that step, you're going to find yourself distributing 3 times and then combining like terms anyway. So let's distribute this 7. 14x plus 70 equals 24x plus 30. Let's subtract 14x from both sides. Subtract 30 from both sides. Divide by 10. X equals 4. Did you get x equals 4? I hope so. Going back to the maze, that takes us here. And now that takes us to this problem. Let's solve for x here. I'd like you to set this problem up. We will solve it together, but on your piece of paper or whiteboard, wherever you're working, see how you would set up this problem. So go ahead and set it up. Okay, so this one, when you set this up, the piece on the outside over here is x minus 3. The length of the whole thing is going to be these two pieces added together. So that'll be x minus 3 plus x plus 1. The piece on the outside here is 6, so the length of the whole thing will be 6 plus 15, or 21. So now let's solve this together. In Algebra 1, you should have learned how to multiply binomials together. Maybe your teacher used a method called FOIL, which stands for first, outside, inside, last. Maybe they didn't use that method, they used a different method. Essentially, we're doing the same thing. It's also possible maybe you used a box method. If that sounds familiar, you can use that. What we're essentially doing is multiplying x and 2x together, so we get 2x squared. We're multiplying x and negative 2 together, negative 3 and 2x together, and negative 3 and negative 2. Whichever way you multiply these, we're going to get the same result, whether you used FOIL, the box method, or some other method. And 6 times 21 is 126. We're going to combine our like terms here. And then we have to solve for x. So now this becomes an Algebra 1 problem where we have to factor or solve a different way. Now, because we are on a maze, it's almost multiple choice. So I'm going to cheat a little bit in the sense. First, I'm going to make this equal to 0. So I'm going to subtract 126 from both sides. So this becomes minus 120 equals 0. You could use Desmos, graphing, if you know how to do that to solve. You could factor it. You could use a quadratic formula. Personally, I'm going to take the answers that are on my paper. Go back to the beginning here. I know the answer is either 14, 10, 18, or 17. So I'm just going to take those numbers and plug them in and see if they work. Now the answer can't be 14 because that would take me in a loop, right? If I went to 14, then I'd become in a background. So the answer is not 14. So the answer is now either 10, 18, or 17. So I'm going to take a 10 and just plug it in for x and see if it works. Okay, so this would be 2 times 10 squared minus 8 times 10 minus 120. 10 squared is 100, times 2 is 200, minus 80 minus 120. Does that equal 0? 200 minus 80 minus 120. We got lucky on the first try. It does equal 0, so our answer has to be x equals 10. If you would like to see this factored, or the quadratic formula, or what else did I say? Desmos, reach out to me and we can do that together. You won't see one like this on an SOL or an assessment for this class. However, you are still required to remember stuff from Algebra 1 because you'll be using it again next year in Algebra 2. Okay, so the answer is x equals 10. Going back to our maze, we are following this path. Okay, so let's look to see what we're doing. Finding the length of PQ. Try that now. Try finding the length of PQ. So your answer, you should get PQ equals 20. Did you get 20? If not, let's check what we did. First, make sure you set it up correctly. The piece on the outside here is 9. The length of the whole thing will be the sum of these two pieces. So 9 plus x plus 4. Here, the piece on the outside is 10. The sum of the whole piece will be 10 plus x plus 1. I combined my like terms. 9 plus 4 is 13, and 10 plus 1 is 11. So then we are going to distribute the 9, and we'll distribute the 10. 9 times x is 9x. 9 times 13 is 117. 10 times x, 10 times 11. And now we solve for x. I subtracted 9x from both sides, and then I subtracted 110 from both sides, and I got x equals 7. X equals 7 is lovely, but it doesn't answer the question. So I got to take that 7 and plug it back in over here. So for PS, that's going to be 7 plus 4, which is 11. So the length of PQ be 11 plus 9, that's 20. So when we go back to our maze, we are going to follow 20. Here it is. Oops. Here we are, following 20. We are going to find the length of VZ. Somehow my PowerPoint keeps skipping around on me. There it is. Let's find the length of VZ. Try this one now. Okay, so here I have this problem set up for us. The piece on the outside is x plus 4. The length of the whole thing will be x plus 4 plus 19. Over here, the outside piece is x plus 2, and the length of the whole thing is x plus 2 plus 29. And I simplified what was inside these parentheses. Now, my trick of like narrowing down the answers doesn't help here because it wants us to find VZ, and we would have to solve for x first to find that. So we're actually going to solve for x here. And I'm going to multiply each of these binomials together to do that. If you liked the box method, just a little review from what that is you put your x plus 4 here and your x plus 23 here, or vice versa, and then you multiply each thing in the box. So x times x is x squared, 4 times x is 4x, x times 23 is 23x, and 4 times 23 is, what do we get? 4 times 23 is 92. And then you would add all of these together and you would say, okay, these multiplied are x squared plus 4x plus 23x plus 92. And then you would combine your like terms. So you get x squared plus 27x plus 92. If you did it the FOIL method, you got x times x, which was x squared, x times 23, 4 times x, and 4 times 23, and you end up with the same thing, x squared plus 27x plus 92. Over here, I'm going to multiply x plus 2 times x plus 31. And if you've never seen this box method before, but you like it, you're welcome to use it. X times x is x squared, 2x, 31x, 62. So we end up with x squared plus 2x plus 31x plus 62. Combine our like terms, 33x plus 62. And now here's a beautiful thing. Notice that you have an x squared on both sides. I'm going to subtract x squared, and those will end up canceling from both sides. So then we end up with just the equation 27x plus 92 equals 33x plus 62, which we can solve. Subtract 27x from both sides. What do we get here? 6x. Subtract 62 from both sides. Divide both sides by 6. We get x equals 5. Now what I can do with that 5 is plug it in over here. And so Vy is now 7. So the length of this whole piece, Vz, will be 7 plus 29, 36. So we can go to our maze and choose 36. That was a little bit more algebra than you would see on a geometry SOL, but again, it's good review for when we take Algebra 2 next year. All right, let's see here. Let's find x in this one. This is where we are in the maze. Okay, if the algebra part is throwing you for a loop, at least set it up. You can definitely set up this problem, and then we can solve for x together if needed. So at least try setting this one up and solve it if you can. Okay, so I'm going to talk you through two ways that you could solve this. The first way is the algebra way. So the piece on the outside is x minus 2. The length of the whole thing will be x minus 2 plus 5. Here the piece on the outside is x, and the length of the whole thing is x, so that becomes x times x. When we simplify, we get x minus 2, and then in the parentheses here we get x plus 3. X times x is x squared. So now here's where we can differ where we solve. If you solve it the algebraic way, you will multiply the x minus 2 and the x plus 3 in the method of your choosing, the box method or FOIL or however else you multiply those binomials. After you simplify, you get x squared plus x minus 6 equals x squared. I subtract x squared from both sides, leaving me with x minus 6 equals 0, which means that x equals 0. The other way that you could solve this is using Desmos. Okay, Desmos, what you'll do is you will make one equation the left side, so we had the x minus 2, x plus 3, and you'll make the second equation the right side of the equation, x squared. Where these two functions intersect each other, it will be our answer. So when you click, you see that they intersect at 636. And if you don't see that right away here, you can zoom in to see that. Well, now I lost it. Give me a minute. There we go. Okay, and we see that they will intersect. Where did it go? It got so little on me. Here it is. At 6. There it is. And if you click it close enough, it will kind of lock into it. They intersect at 636. We're solving for x. We don't care about the y value. We're solving for x. The x value is 6, and you do get to use Desmos on the SOL. So maybe you want to play with that and figure out how to use Desmos to quickly solve your equations. Although on the SOL, they wouldn't give you one this challenging. Okay, so our answer is x equals 6. So we'll go here. We're following x equals 6. Oh, we're getting close to the end here. Okay. Let's solve for x over here. Okay. Set it up, multiply it out. If you need help with the algebra, stay tuned. I will do it after you at least set it up. Try that now. Okay, so to set this up, you should have at least been able to set this up. The piece on the outside was 9. The length of the whole thing will be 9 plus 7, or 16. Here, the piece on the outside is x minus 1, which is also the length of the whole thing. So you get x minus 1 times x minus 1. You could, at this point, enter this right into Desmos. I simplified it a little bit before I did that. 9 times 16 is 144, and I did multiply my binomials here, combine my like terms, and got x squared minus 2x plus 1. But then I went to Desmos to solve this. So I enter y equals 144 because that was the left side of my equation. And then y equals x squared minus 2x plus 1, since that was the right side of my equation. I'm looking to see where those two things intersect. That will be the solution. So I found the point on my graph where I have the y equals 144 and the x squared minus 2x plus 1. They intersect at the point 13, 144. We're solving for x. So I look at the x value of that intersection, which is 13. So the solution here is x equals 13. And there's my cat again. Okay, so we go to our maze. And 13. Okay, we are almost there. We have one more problem to solve. We want to find the length of CD. Oh my goodness, my PowerPoint doesn't like me today. There it is. Let's find the length of CD. You already know what the answer must be. So go ahead and set this up, and then we'll solve it together if you need help doing that. Do that now. Okay, so the piece on the outside here was x. The length of the whole thing will be x plus 7. The piece on the outside here is 15, which is also the length of the whole thing. I combined my like terms. X plus x is 2x. I distributed my 2. And then I wanted this to equal 0 just because I know that's going to be a little easier to graph in Desmos if I can just find a 0. So I subtracted 225 from both sides. I didn't have to do it that way. I could have left it like this and used Desmos to solve. You also don't have to use Desmos. You could factor if you are good at factoring, and you're welcome to do that. I used Desmos, so I entered 2x squared plus 2x or plus 7x minus 225 as one equation, and y equals 0 as my other equation here. Okay. And then I found, where did these two intersect? So I looked on my graph, and here they're intersecting right here at 9, 0. I'm solving for x. My x value is 9, so x equals 9. And now that I know that x equals 9, I can plug that in. 9 plus 7 is 16. This is 9, so the length of this whole thing is, the length of just CD is 16. So our answer is 16, and voila, we have made it to the end of the maze. I hope this was a helpful review. You'll be using this when you take your quarter assessment. Stay tuned for the attendance word that will appear in a interaction. So make sure you write that down and do the attendance quiz. Have a great day, everyone.